In this session, we're going to learn more about absolute value equations. We saw from before that if you have the absolute value of some expression equal to a number, and that number is greater than 0, then there are two possible solutions. Either z is equal to that number, or z is opposite that number. And that provides us a strategy for solving problems with absolute value. For example, the absolute value of x plus 4 is equal to 9. Then according to our statement, the only way we're going to get equality out of this is if x plus 4 is equal to 9 itself, or x plus 4 is equal to negative 9. Those are the only two possibilities that will have equality. And to solve, subtract 4 from both sides, and we get x is equal to 5 as our first solution. And then subtracting 4 from both sides of the second equation, we have x is equal to negative 13. You can check your answer by substituting 5 into x. 5 plus 4 is 9, and what's the absolute value of 9? We got 9. And checking the negative 13, well, negative 13 plus 4 is negative 9, and what's the absolute value of negative 9? 9 as well. Let's take a look at the geometry. What makes x plus 4 equal to 0? X equal negative 4 does. So on the number line, we're going to mark our origin at negative 4, and now if we start counting out 9 units to the right, 9 units to the left, let's see what happens. If we start at our origin at negative 4 and count out 9 units to the right, 1 unit at negative 3, 2 units at negative 2, 3 units would put us at negative 1, 4 units would put us at 0, 5 units would put us at positive 1, 6 units would put us at positive 2, 7 units would put us at positive 3, 8 units would put us at positive 4, and 9 units to the right puts us at positive 5. So 9 units to the right of negative 4 is that number that we obtained from before, that number 5. And likewise, if we count out 9 units to the left of negative 4, 1 unit at negative 5, 2 units at negative 6, 3 units at negative 7, 4 units at negative 8, 5 units at negative 9, 6 units at negative 10, 7 units at negative 11, 8 units at negative 12, and 9 units to the left would put us down at negative 13. And remember, absolute value represented distance away from the origin. If we have that origin at negative 4 and 9 units to the left and 9 units to the right, we have the two solutions that we obtained algebraically. Let's take a look at another example. We have the absolute value of 2x minus 5 is equal to 7. Well, we know that we're going to have two possibilities. Whatever x is, when you multiply it by 2 and subtract 5, you either have to be at 7 or you have to be at negative 7. 2x minus 5 has to be 7, or 2x minus 5 has to be negative 7. Because what's the absolute value of 7? 7. And what's the absolute value of negative 7? 7 as well. 2x minus 5 is equal to 7, in which case we add 5 to both sides, and we end up with 2x is equal to 12. And now we divide both sides by 2, and we get x is equal to 6 as one of our solutions. Solving the second equation, we have 2x minus 5 is equal to negative 7, and when we add 5 to both sides, we get 2x is equal to negative 2, and now we divide both sides by 2, and we get x is equal to negative 1. And you can check 2 times 6 is 12, and 12 minus 5 is positive 7, and the absolute value is 7, we get 7. And negative 1 will work out as well when you check it. Let's take a look at one more example. If we have the absolute value of 7x minus 2 is equal to 0. In the previous problems, our number on the right-hand side was a number greater than 0. And this time we have equal to 0. To work this problem out, we have to think about what that means. What's the only way to get 0? The only way to have absolute value of 0 is to be at 0 itself. There's only one possibility. 7x minus 2 has to equal 0. And then you add 2 to both sides. You get 7x is equal to 2. And now you divide both sides by 7. And we have only one solution. X is 2/7. So when our right-hand side is 0, there's only going to be one solution to the problem. When the right-hand side is positive, there are two solutions to the problem. And now let's see what happens when the right-hand side is a negative number. Let's say we have the absolute value of 3x minus 5 is equal to negative 1. Here you have to think about the meaning behind absolute value. Absolute value represents distance away from the origin. And is distance ever going to be a negative number? And the answer is no. So in a problem where you have the one side is negative, the other side is a positive, a negative number will never equal a positive number. This problem has no solution. Sometimes you'll see problems where this no solution case is disguised. For example, we have the absolute value of x plus 7 plus 5 is equal to 2. In solving equations, one of the first things you want to do is to simplify the equation. And simplify can mean a lot of things. One thing it means is to collect like terms. In this particular equation, we want to get the 5 on the other side with the 2 as the first step. Subtract 5 from both sides. That gives us the absolute value of x plus 7 is equal to negative 3. And now there's that stopping point. No solution again, because the right-hand side is negative, whereas the left-hand side will always be greater than or equal to 0. The absolute value always produces something greater than or equal to 0.